Okay, we're going to start looking at the graphs of sine and cosine curves. So we're going to start out with just what the parent functions look like. Okay, now if you've got your trig chart or your unit circle handy, that's where these points are going to come from. I will try to make a table down here below this graph so that you can follow along. Okay, the other thing that I'm going to suggest is you can use your calculator, okay, but you're going to want to be aware of the window, okay? So the window is going to be really important as to how you have that set up on your calculator. Okay, so here's one suggestion for you, kind of as a fallback. All right, you can work in radians or in degrees on your calculator. Okay, so when you go to the window, you've got your X min, X max. Okay, I'm gonna pattern what I put in my calculator against what is the size of our graph that we have on our notes. Okay, so you'll notice I go from negative 2 pi to positive 2 pi. So that's going to be my X min and my X max. And then it goes to, well, if we do every other tick mark on the y-axis, we would have 1 and 2, and then -1, -2. So you might want to choose that for your y value. Here in what I wrote down was a -3, +3. That would be fine too. So I will change those. Now, in your x min, if you go -2 pi, so I'm going to go -2, I got to go second to get my pi. As soon as you enter, hold on, I got to try it again, -2 pi. As soon as you enter and advance to the next line, it's going to change it to a decimal. Okay, so you know that pi is approximately 3.14. So our 2 pi and our -2 pi is going to be about 6.28. Okay, the y scale. If you look at the tick marks, you'll see that every other tick mark is, it's labeled pi over 2. Okay, and then 4 tick marks over, it's pi. All right, so if the second tick mark is a pi over 2, then that means this first tick mark would be a pi over 4. Okay, similarly, going the other direction, it would be a negative pi over 4. Okay, then a pi over 2. I skip a tick mark and go to pi. Well, what's halfway between pi over 2 and pi? Okay, think if the cups of sugar, half a cup of sugar, whole cup of sugar, what's in between? Well, 3/4 of a cup of sugar, so 3 pi over 4. Okay, so you can see that each of these tick marks is in increments of a quarter pi. So we have a 1 pi over 4, 2 pi over 4 is your pi over 2, 3 pi over 4, 4 pi over 4 is your pi. And then this next one would be 5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2. And then 7 pi over 4. And then 8 pi over 4 reduces to 2 pi. Okay, you would have the same thing going in the negative direction. So this would be a -3 pi over 4. This one would be a -5 pi over 4 and -7 pi over 4. Okay, so if I want to use that as my scale, let me do this. Let me do this here. Let's change this. And we'll go pi over 4 so that it matches my graph. So pi over 4. Now, if I was doing the same thing in degrees, that 5 pi over 4 would be a 45 degrees. Okay, so my scale would be 45 degrees, but I'm going to work in radians. So let's change this. X scale needs to be pi divided by 4. Okay, and again, it's going to change it to a decimal. We can go -2, +2, scale of 1. That's fine. Okay. Now let's, oops. Hold on, did I mess up my window? Okay. All right, let's go to y equals. I already have a few equations in here. So we're going to look at the sine x. Okay, so I'm going to select that one. It'll be blue, and I'm going to graph. Okay, so that's what your sine curve looks like. All right, and again, you can use your calculator, that's fine. But I want to take time to go through and look at the points and show you where these points come from so you understand how the graph is formed. Okay, so we're going to move over to your unit circle or your trig chart if you've got it handy. Okay, so we're just going to do an XY table. I'm going to go sideways. So this is X, and then this would be your Y. Y equals sine of X. We're going to use the same increments that we have on our chart. So we're going to look at the units of pi over 4. Okay, so we're going to first start with 0. Then we'll look at pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Okay, so 0. If you look at your trig chart or your circle, if you look at 0, the point on your unit circle is 1, 0. Okay, well, if you remember, if you want to find the sine and you have an ordered pair on this unit circle, the sine is the y value. Okay, so if I look at that ordered pair, 1, 0, the y value is 0. Okay, so the sine of 0 is 0. Okay, now I want the sine of pi over 4. Well, pi over 4 is about right here. If you look at the ordered pair, it's a root 2 over 2, root 2 over 2. Okay, again, the sine is the y value. So the sine of pi over 4 is root 2 over 2. Okay, pi over 2, that's this point here. That would be the ordered pair over 0 up 1. So the y value is 1. Okay, 3 pi over 4 is over here. And then that ordered pair would be a negative root 2 over 2, root 2 over 2. Again, the y value, root 2 over 2. At pi, my ordered pair is a negative 1, 0. The y value, 0. So sine of pi is 0. Continue around your circle like that. So 5 pi over 4, the y value is going to be a negative root 2 over 2. At 3 pi over 2, that's down here. So this is the ordered pair 0, negative 1. Y value, negative 1. 7 pi over 4, y value, negative root 2 over 2. At 2 pi, you are back around. We've done one complete rotation, and the y value is 0. Okay, so if we go to plot these points, so 0 is 0. At pi over 4 is root 2 over 2. Okay, so root 2 over 2, if you change that to a decimal, the decimal approximation is about 0.707, so just under 3/4. You're just going to estimate. Okay, now I labeled my second tick mark here as 1, so then of course that means this one is a half. So at pi over 4, you're doing about 0.7, about 3/4. Okay, pi over 2 is 1. 3 pi over 4 is about 0.7. Pi is 0. 5 pi over 4 is a negative 0.7. 3 pi over 2, negative 1. Then we have another, about a negative 0.7, and then back to 0. Okay, so we get this nice curve. Okay, so you can go back, look at your calculator. We'll compare it to the calculator in just a minute. So you have this nice sine curve. If you notice on your calculator, it repeats. So this pattern is just going to continue. Okay, now as far as going negative, okay, so a negative pi over 4. Well, negative, let's maybe use a different color. Negative would be going clockwise around your circle. So right here would be a negative pi over 4, okay, which is the same as 7 pi over 4. Okay, a negative pi over 4 is coterminal with 7 pi over 4. So its y value is that negative root 2 over 2. So at negative pi over 4, we're at a negative 7.07. Okay, a negative 1/2 pi would be down here. Negative pi over 2 is the same place as a positive 3 pi over 2. And the y value is a negative 1. Okay, so it'd be a negative 1. Negative 3 pi over 4 is going to be around here. This is also going to be a negative root 2 over 2. So about right there at negative pi. Okay, we are halfway around the circle. Negative pi is the same coterminal angle as positive pi. Okay, so that y value is 0. Okay, negative 5 pi over 4. It's going to be a positive root 2 over 2. Negative 3/2 is a positive 1. Negative 7 pi over 4 is a positive root 2 over 2. And at negative 2 pi, so you've completed another rotation of your circle, takes you back to 0. Okay, and then what you'll notice is makes this nice curve. And you can see that it's just a copy of that first curve that we did. Okay, so look back at your calculator. You can see it's that same curve. Okay, on your calculator, you can trace. So right here at 0, 0, we're at the origin. Okay, you can trace, you can scroll left and right. Now you'll notice that, of course, it's all decimals. All right, now I can choose a specific value. Like here, this high point is a root 2 over 2. So is a pi over 2. So I can type in pi divided by 2. Now, as soon as I hit enter, it'll change it to a decimal, but it will go to that spot, and you can see we're at 1. Okay, another place you could do is you could just do pi. Okay, at pi is going to be back to 0. So you can see that. Again, you can see the x value is about 3.14. Okay, so your calculator is changing everything to a decimal. Okay, so that is what a parent sine function looks like. I'm going to pause. This will be the first part of your video. When we come back, we'll look at some more of the graphing. And so I will see you in